So using a pipette out exactly 50 ml and transfer it to the clean beaker. So once you transfer, this is the conductivity cell. So keep the immerse the conductivity cell in the acid mixture. So once you immerse, switch on the instrument and you get some value, that is your zeroth conductivity, that is 16.7. So note down the values at the zero value is 16.8. Now in the pipette, fill the pipette with sodium hydroxide solution of 0.5 normal. So adjust the sodium hydroxide to the 0th level. Now you go on adding a 0.5 cc of sodium hydroxide to this acid mixture, which contains concentrated hydrochloric acid as well as the acetic acid. Go on adding 0.5 cc and shake well the contents and note down the change in the conductivity values. So you can see conductivity goes on decreasing. Initially it was 16.6 at the 0, now 0.5 we are noting down, like 0.5 it is 15.4. Then go on adding again 0.5 cc from the pipette. Shake the contents thoroughly and note down the conductivity value, that is 13.3 after 1 cc of addition. So here you can see, so 12.4 is the value which is recorded for 1.5 cc. Now 0 cc you have to record, that is value without adding sodium hydroxide, that is 16.6, and 0.5 that is 15.4, and for 1 cc it is 13.3, in 1.5 cc it is 12.4. Now go on adding likewise So stir the reaction mixture, stir the contents, and note down the change in the conductivity. So now it is coming somewhere like 9.4 or 9.3. Okay, it is decreasing consistently. Now you can see consistent decrease 8.5. So note down the value of 8.5. So here how long you have to do the addition of sodium hydroxide to get the conductivity value is that. So original value is 16.6. So conductivity decreases, you can see consistently. So it will increase after a certain addition of sodium hydroxide till you get original value 16.6. It comes almost 13 to 14 cc. So up to that you have to add sodium hydroxide.
3.3 slow ಆಗಿ decrease ಆಗಿದೆ.
It's okay. So once you complete the addition of up to 14 to 16 ml, you get your original value of 16.4. Now it is tabulated here, you can see. So in the columns you will have a volume of NaOH starting from 0.5, conductivity value 16.6 initially. It goes on decreasing and it will increase after the certain addition, like up to 11th addition you are getting again original value 16.4. So you have to stop here, and once you stop you have to plot a graph of conductivity against volume of NaOH. So the conductivity against volume of NaOH graph looks like this. Conductivity on the y-axis, volume of NaOH on the x-axis. You can take a scale of 1 unit is equal to 1 cc on the x-axis, and again 1 unit is equal to again 1 cc on the y-axis. You get a graph like this, the first straight line, and the second straight line corresponds to the increase in the slight increase in the conductivity, and the third straight line corresponds to the steep increase in the conductivity. So intersect these straight lines, and from the intersection of these three straight lines, the volume V1 you will get it on the x-axis, the intersection points, and second intersection point you will get in volume V2. So volume V1 corresponds to the amount of HCl consumed, amount of NaOH required to consume completely the hydrochloric acid. Volume V2 minus V1, so the V2 minus V1 corresponds to the amount of acetic acid. So by knowing the volume and by knowing the normality of NaOH, you can calculate the normality of acetic acid as well as the normality of acetic acid as well as normality of HCl. So volume of NaOH required to neutralize HCl V1 from the graph as I explained. Normality of HCl is equal to normality of NaOH. Normality of NaOH is known, 0.5 or 1 normal into V1 from the graph divided by V mix. This V mix is the amount of acid mixture prepared out. So that will correspond to so much of normal. And once you know the normality of HCl, amount of HCl can be calculated. Normality of HCl into 36.5, you will get so much of gram per dm cube. And similarly, the volume of NaOH required to neutralize acetic acid, as I explained, V2 minus V1. So that corresponds to so much of volume. And normality of acetic acid is equal to N1 V1 is equal to N2 V2 again. So multiply with V2 minus V1 ml divided by V mix. V mix is the amount of volume of acid mixture prepared out. So amount of acetic acid is normality of acetic acid into 60. So you will get so much of gram per dm cube. So at the end, the result will be amount of HCl is equal to so much of gram per dm cube, and amount of acetic acid is equal to so much of gram per dm cube.